All right, to prove that this is an identity, the first step is going to be to decide on which side to start with. We're going to start with, usually we start with the most complicated side. All right, so that would be this tan plus cotan, because this is one term. This is two terms being added. So let's do that. Let's write out tan x plus cotan x. And then what we're going to do is a series of steps to get ultimately to this secant cosecant of x. That's where we want our steps to end. And we're going to use identities and algebraic properties to do that. So first, I'm going to change this to cosines and sines, hoping that I can combine these two things together, because ultimately I want one term. Now I have two terms. So I'll write this as sine of x over cosine x plus cosine x over sine x. Okay. Now I'm going to do a common denominator. So I'm going to multiply this fraction, should give myself more space, excuse me, by sine over sine, and this fraction by cosine of x over cosine of x. All right, that gives me a common denominator of sine x cosine x, sine x cosine of x. And on top I have sine squared, that's sine times sine, plus cosine times cosine, that's cosine squared. Now, anytime you see sine squared plus cosine squared, some sort of bell should go off in your head that is equal to 1. So let's change that. 1 divided by sine of x cosine of x. All right? Now here, remember, we're trying to get to secant cosecant. So we can imagine what the step before this might be. It might be something like 1 over cosine times 1 over sine. That might be the step before the end. Okay? And I think we're close to that. So I can break this fraction up into 1 over sine of x times 1 over cosine of x. If you're not convinced of that, try going back this way. Multiplying numerators, you get 1 times 1. Multiplying the denominators, you get sine x cosine x. And so that 1 over sine of x becomes cosecant. And this becomes secant of x. And there, we have shown that this expression on the left can be turned into this expression on the right using algebraic techniques and different properties of trigonometric functions.